Okay, today we're going to learn equations in two variables. Remember during first semester I said, don't use two variables until, we get to second semester. Now, this is a chapter where we get to use two variables, okay? All right, so, let's first review how we normally solve equation in one variable. Something like this, 2x minus 3 equals to 7. You all know how to solve this, don't you? All you have to do is add 3 to both sides and divide both sides by 2, you get x equals to 5. And of course you could write it in the set notation using brace, like that. All right, and your solution is it looks like it's just one number, isn't it? All right. For equations in two variables, your solution would not look like this, just one number. It will be a little bit different. Let's see how that will look. Okay, so let's take a look at this equation. Take a look at it. Now here's your first equation in two variables. Very simple equation. It says x plus y equals to 3. Okay. As you can see, we have two variables, x and y. Now, do you have to have x and y? I mean, do we have to use these x and y? No, it could be a, b, c, d, whatever letters you like. Probably use one. You probably don't want to use like o. Okay, that's probably not a good variable. All right, x plus y equals to 3. Now, whenever you have equations with two variables like this, what you got to do is, here's first step. You solve for one of the variable. Okay, and the variable that we solve for is, you can solve for x or y, it doesn't matter, but I would suggest you solve for y, the one that comes later in the alphabetical order. So don't solve for x, right? Solve for y first. But does it matter if you solve for the other one? Like I said, no, but it's best if you solve for the one that comes after the other one in alphabetical order, okay? So solve for y, and we know how to solve. Do you know how to solve for y here? Yeah. What do? We subtract both sides by, or add both sides by? Negative x, exactly. So when we do that, you simply get subtract or add both sides by negative x. Y equals to negative x plus 3. Notice I wrote this in standard form, right? Kind of on the right side, right? So y equals to negative x plus 3 there. Okay, so our original equation was x plus y equals 3. We got y equals to negative x plus 3. In other words, we have solved for one of the variable, y. Okay, that's our first step. Okay, and our second step, let me show you. Let me move this up. Okay, step 2 is since after you solve for y, write this down. This is the key step. You plug in x with nice number. Okay, that's kind of like, what do you mean nice number? We'll talk about this. So we got y equals to negative x plus 3. You plug in x with nice number in a table. And what does the table look like? It looks something like this. It's got 3 columns. Yeah, some of you remember this from intro, right? You did this before. So first, you have a column for x, right? That's the variable we're going to plug in. And then we got the column for what y equals to, right? In terms of x. So that's why we solve for y. Does that make sense? So we got a column for x. We got a column for really y. Because it tells you what y equals to in terms of x. And then you're going to get your solutions. And the solution will look like x comma y. We'll talk about what that means in a minute. So we're going to get solution or solutions. Okay, so write that down. We're going to do a little table. It's going to have 3 columns. X. The other one is y. It tells you what y is in terms of x. And the last column is your solutions. In this form, x comma y. So write that down. I'll wait. So I said plug in x with nice number. What do you think would be a nice number to plug in for x? Again, you have, like, you can plug in any numbers you like on a number line. Choose anything. What's the nicest number on a number line? Some of you said 1. There's actually one that 0 is actually a lot nicer than 1. 1 is nice, you're right, but isn't 0 the best number to plug in? So, do you have to always do this? No. Let me just show you how to do this, and then you see what to do next. So it says plug in any nice value for x. You can plug in 1, you can plug in 1,000, you can plug in 1,000,000. I'm going to plug in 0 because that's the easiest one. And of course, when you plug in 0, this is nice because what happens now? Thank you. What happens when you do that? By the way, whenever you plug in, right, substitute in, what did I ask you to use when you plug in something? Use parentheses. Thank you. So when you do, you see you get something like this. And so you get y equals to 3 right away because 0 times anything. This time it's 0 times negative 1, isn't that right? So 0 times negative 1 is 0. 0 plus 3 is 3. So we got y equals to 3. And guess what our solution is? It says solution is going to look like x comma y. Guess what our solution for this x equals 0 will be? 0. So it's x comma y, so we're going to get 0 comma 3 is your solution. Okay? Does that make sense? And what do we call this sort of, when you write something like 0 comma 3 with parentheses, what do you call this? It starts with O. It's 2 words. Yes? Coordinate. Yeah, it starts with O. Yeah, it could be coordinates in terms of graph, but when we have something like this, yes? Order pair. Very good. Order pair. By the way, why don't they just call it pair? We got pairs, okay? Why do they call it order? What order do you think? Yes, Sammy?
Because when you're graphing, there's an x-axis and a y-axis, and that's the order you graph.
Exactly. This is the order in which you graph also, and it's in that alphabetic order, x comma y. Does this say, it's not y comma x, is it? Yeah, that's why it's called order pair. Does that make sense? Yes? It's in alphabetic order pair, x comma y. What if I had variables like a, b? What would this be in? A comma b or b comma a? A comma b. Exactly. That's why it's called order pair. All right? So I plug in nice number like 0. That's fine. So I found the solution, right? Because look, if I plug in x equals 0, y equals to 3, look at my original equation. It says x plus y equals to 3, right? So look, if x is 0, y is 3, we get 3. The solution is correct, right? Left side is equal to the right side. Does that make sense?
Wait.
So we're done, right?
No.
Are we done?
No.
Okay, some of you say no. Okay, I want you to discuss with the group. We're not done. Why are we not done? Okay, go ahead. Everybody think about this. Go ahead. Why are we done here? All right. What did your group come up with? Camila, what'd your group say? You need to check it. Okay, we could check it. Let's plug it in. 0, 3. Yes, it does come out to be true, right? 0 plus 3 gives you 3. So this, yeah, we checked. But turns out we're still not done. Even if you check, that's a good idea. But yeah, we're still not done. How about different group? What did your group come up with? Royce, what did your team come up with?
I don't know. We just said that we need
Oh, you need 3
or more.
or more solutions?
Yeah.
Kind of. That's sort of right. Okay. Aiden, what did your group?
We also need to find out what x is.
What x is? We know what x is. X equals 0.
X equals 0.
I mean, what y is.
We know what y is. Y is 3.
No.
Okay, good try, good try. That's sort of a good. Okay, Dana, what did your group come up with? Oh, yours. Did you want to add something? Even though she's saying. Say it again. Oh, you know it's going to be a line? Okay, good. Some of you remember this. This is going to be because it's a linear equation. Hold on. No, you do need to plot it. I didn't ask you to plot. I just said find the solution. Good point. Jason, what did your group come up with? Not so sure? Okay, Jason, let me ask you this. Okay, some of you have an idea. Jason, let me ask you this. Look at our original equation. It says x plus y equals to 3, right? In other words, when you add two numbers, it equals 3. So we found that if x is 0 and y is 3, we get 3 when you add it together. Is that the only way to do that? Can you give me another case where if we add two numbers, you get 3? What about 1 plus what gives you 3? 2. Guess what? 1 comma 3, that order pair, is also a solution.
What?
That makes it equal to 3. Could x be 2?
Yes.
What will y be then? 1. What's 2 plus 1? 3. See, that's another solution. Now, what if, can x be like negative 10?
Yeah.
What if x is negative 10? What will y be? No, not 13. If x is negative 10, y must be? Wait, did I say that? You're right. 13. Yeah. I was wrong. Aaron was right. If x is negative 10, Aaron says y has to be positive 13 for it to be 13. So Aaron's correct. If x is negative 10, y has to be positive 13. Sorry, Aaron, you're right. Does that make sense? So let me ask you now. I want you to discuss this with the group. How many solutions or order pairs do you have as solution on this equation? Everybody think about it. How many solutions could you get on this? Everybody think about it. How many possible solutions are there for this? So, how many groups said, oh, you could have... Well, actually, let me ask. How about Eugene? What did your group say? How many solutions could you get? As many as you want, you're right. The way we say this in math, we say there are infinitely many solutions. Infinitely many. So, no. We know what x and y will be. Look, for example, take a look at this now. If I plug in x equals to 1, I get y equals to 2, right? That's obvious. Do I stop there? No, I could plug in x equals to 2, then y is going to be 1. And I could plug in x equals to 3, x equals to 4, can I plug in x equals to like negative half?
Yeah.
Can I plug in x equals to 0.0007? You could always find y that makes it equal to 3 when you add it together. So they are, you could keep going, they are, write this down, infinitely many solution. There are infinitely many solutions in this, okay? So write that down. So some of you ask, okay, so some of you ask, does that mean that, can I plug in any order pairs I want? Like,
Yeah.
No.
Yes.
Yeah.
like can I plug in, look, can I plug in 1, 1?
No.
Yeah, infinitely many solution does not mean you could plug in any order pairs. But there are order pairs, there are particular order pairs that will work. And there are infinitely many of these. Does this make sense? Yeah, look, we found 3 so far, but you could keep going on this, right? You could imagine plugging 3, right? X equals 3, then y has to be 0 and so forth, right? If you plug in x equals 4, what must y be? -1. There are infinitely many order pair solutions, but not every order pair will be a solution. Does that answer your question? So please be careful. Okay, even though there are infinitely many of them, you can't just randomly choose any order pair and think that it's going to be a solution for it. Does that make sense? Yes? Yeah?
Yes, sir.
Carolyn, look. Take a look at the table we made. 0, 3 is a solution for this equation, right?
Yeah.
Also 1, 2. Also 2, 1. And you could keep going forever. You could plug in any values of x. You give me any values of x on a number line, I could give you which y will make it so that when you add it together, it equals 3. So there are infinitely many solutions. Does that make sense? Now, all these infinitely many solutions, on your homework tonight, if I ask you to list all the solutions, is this possible? No, why not? There are infinitely many of them. So this is how they get creative. Because, listen, hey guys, listen, you're right. It'll take you forever. It's impossible, right? So because of that, they're gonna get creative. They're gonna get creative, and they're going to say something so that they're gonna give you these sort of question in a way so that you don't have to write everything. Let's see how they get creative in that way. Let's see if you can figure this out. Here's example 2. Everybody take a look at this now. Okay, so take a look at this now. It says, solve this linear equation. Solve 3x plus 4y equals to 12 if the x and y are whole numbers. Okay, so you're gonna like this because if they don't stay whole numbers, then this problem is impossible to list them all out. It says solve this if x and y are whole numbers. By the way, what are whole numbers? You guys remember this? Positive integers. Do we include 0 or do we not include 0? Remember, here's a hint. HWOLE for whole number. Do we include 0 or not? Yeah, we include 0. Remember whole numbers, you include 0? Right? Whole number. Natural numbers, you don't include 0. You guys remember that? Whole number, you include 0. So these are numbers that are not negative or some decimals or fraction, right? It's starting with 0. So 0, 1, 2, 3, and 4, forever. Now, how does this help us to list all the solutions? Because for these linear equations, there are infinitely many solutions. Now, so let's just kind of blindly go through what we just talked about. What is our step 1? Look at your first example. Step 1 was 2. Michael? No. First, look at your first step. What is our first step when, yes, Aaron?
Minus x, or add negative x to 3x.
Yeah, why are we doing that? To get the y by itself. Very good. Everybody go ahead and solve for y. So that's step 1. Step 1 is to solve for y. Okay, go ahead. Everybody try that. Oops. Go ahead. So did you all add both sides by -3 like this? And then you get 4y equals to -3x plus 12. Did you all divide both sides by 4? Now, do I have to divide 4 to just, one of the terms or both of the terms? Okay, so you should have all gotten this. Y equals to -3/4x plus 3. Some of you say, well, why don't we just solve for after this? Why don't we plug it back into the original equation, solve for x and so forth? You don't want to do that because you're plugging the same equation to itself. You get identity equation every time you do that. Okay, so you don't want to do that. Okay, so if you don't want to, if you have one equation, you can't solve for y and then plug it back into it's the same one. You're just actually plugging in yourself into the same equation. You get an identity equation every time. You don't want to do that. Okay, so after this, step 2 is make a table. Go ahead and make a table. And now everybody think about what is the best number, easiest number to plug in for x, our first one. Okay, everybody, you should all know that one. Okay, go ahead. Okay, did you all choose 0? Okay, good. Okay, what do we get? You could actually just look at it and tell you, you could all tell me what is your y going to be. When you plug it in, you use parentheses, so of course, you get 0, 3, right? So we found our first order pair, the solution, right? As an order pair. So as you can see, if I plug in x equals 0 and y equals 3, the equation is true. What was our original equation again? Let me move it down a little. Okay, so our original, look out, I wrote down our original equation. It was 3x plus 4y equals 12. Look, when I plug in x equals 0 and y equals 3, don't I get 12 equals 12? So that one works, right? And now, the next number that I'm going to plug in is going to be?
4. Wait, what?
What is, okay, because I'm not done, right? This isn't the only solution that we have. By the way, are these all whole numbers, 0 and 3? Yeah, that's good, right? What if it came out to be 0 and half? Could I use that as our solution? No, because they want our solution to be all x and y to be whole numbers. Does that make sense? Right now, this is good. Now, the next number I'm going to plug in is what? What do you guys think? How many people say 1? How many people say 4? Why not 1? Didn't we plug in 1 last time? Okay, yeah, I could already see. If I plug in 1, guess what? Our solution is going to come out to some fraction. I know that it's not going to really work out. I can see because 1 times 3/4 you get a fraction. Fraction times plus 3, right? If you add fraction plus another whole number, right? Or integer, you're not going to get another whole number and things like that. So I know that I'm not even going to try 1. Am I going to try? Do you think I'm going to plug in 2 next time?
No.
Why? Do you think I'm going to plug in 3? No, look, I can show you. If I plug in 2, it's going to be some fraction. If I plug in 3, it's going to be some fraction. It can't be my solution. Guess what I'm going to plug in? Why 4? Because? Yeah, it's really, I'm going to be plugging in, look at the number in front of x. It's going to be, we need to be plugging in multiples of 4 so that it cancels out with the denominator, right? So when I plug in 4, everybody go ahead and try. I'll wait. Okay, everybody plug in 4. So did you all get 4 like this? Plug in 4. How many people got 0? How many people use the parentheses? Please use parentheses, okay? Because if you don't, you may get this wrong. How do you get 0? You plug in 4, then you get negative 3/4 times 4. Don't you get negative 3? What's negative 3 plus 3? Yeah, okay, 0. So the order pair is 4, 0. So far we found 2 of them, right? What was our first one? 0, 3. The second one, 4, 0. That's good. Because I cannot use, right? When x equals 1, 2, 3, it's not going to come out to a whole number, right? So we're okay so far. Okay. Any questions so far? Okay. A lot of you are asking this question, you know, why do we solve for y by itself? Well, it's because when you plug in what x equals to, you get your value y really easily. You don't have to solve for y again. So you just solve for y in the very beginning, and then you keep plugging in for x, then you get y by itself really nicely. That's why we solve for y. And later, it's going to be really helpful to us. All right, now, what's the next number I'm going to plug in? Am I going to plug in 5? No, 5. If I plug in 5, I'm going to get fraction again. What am I going to plug in next? 8. Okay. Very good question. When do we stop, right? Okay, let's plug in 8. Okay, everybody try. And I claim to you this is when you know when to stop. When I plug in 8, I got y equals to negative 3. How do I know? Now I could just stop.
Because it's negative.
I'm tired.
No. Okay. How about I want you to discuss with your group. Go ahead. How do I know this is now time to stop? Okay. Why don't I just keep on going? Okay. How come I stop here? Everybody go ahead and discuss. Okay. All right. So, let me call on a random person. What did your team come up with? How come we could stop at this point, Joseph? Because it's a negative number. Well, you're right. Why isn't a negative number good? Because we said the solution must be in whole numbers. Whole numbers do not include any negatives. Now, but let me ask you this then. How come I stop? What if I plug in, what's the next number? What if I plug in 12? What if it comes out to be a positive number for y? No, it turns out, look at what's happening. As you plug in, like 12, you get more negative. You're keep on adding 3 to this, right? Guess what? The number is going to be even bigger, negative than this, right? You're going to keep on getting negative. The negative will just keep on increasing. Does this make sense? Yeah, so because you could plug in 12, you could plug in any value that is greater than 4, the multiples of 4, you're going to get a negative value for your y. Does that make sense? So you will see, you could plug in 12, it's going to be a smaller number than negative 3, a bigger negative, right? You know what I'm talking about? Now, some of you ask this question. Guys, does this make sense? So you don't need to keep on going because it's still going to be negative. It's going to get bigger and bigger negative number as your y. Does that make sense? Hold on. Some of you say, wait a minute. Take a look at this. Why don't we then plug in x equals to -4? If I plug in x equals -4, look at the equation. Wouldn't that give you sort of a nice one? If I plug in -4, the 4's will cancel out. You get negative times negative. Don't you get -4 and 0 as your solution? Yeah, x is now what? Can x be negative?
Wait, what?
No, why not? Why can x be negative? Because we want all the solutions to be what?
Whole numbers.
Whole numbers. Do you see? This is a nice. Isn't this kind of a creative way to get you right? Otherwise, you would have to write this. You would have to do this right forever, right? So do you see why this is a creative way to tell you how to write down all those whole number solutions? So what are the two solutions that we found? 0, 3, and what?
4, 0.
4, 0. Write this down. That's your. I wrote it. So those are the only whole number solutions you could have. If I didn't say that, then you could do this forever, right? Okay, does that make sense? All right, so very good. Okay, write that. On your homework tonight, again, you're going to get something like this. Is 5, -1 a solution to this equation? By the way, we just said this. Just because you have a linear equation doesn't mean every single order pair will work, right? Certain order pair will work. How do you know whether or not this order pair will work? All you have to do is what, Jason? Plug it in. Let's plug it in. What do we get? You get 6. Be careful. Please use parentheses. In this case, if you forgot to use parentheses, right, it's really easy to make it wrong, right? So you get 5 minus -1. What is that? 5 plus 1. You get 6. What does 6 equal to? Yeah, not 4. 6 equals to 6. Doesn't equal to 4. Therefore, guess what? This order pair happens to be what? Well, not a solution. Does that make sense? Can you do something like this for your homework tonight? Have a great day, guys. Good.